there has been a request for me to please explain the question in worksheet 1, which I'm going to do now. And this worksheet is important because your next test will definitely have these types of calculations in it. Look at this question. It says you have 0.645 grams of an inorganic compound. Inorganic compounds are compounds that consist of mostly carbons and hydrogens, also oxygens. Sometimes it can have nitrogens in it. In this case, it tells me that it undergoes a complete combustion. Combustion means that there is oxygen involved. It's burning in oxygen. And normally when you burn something in oxygen, your byproducts are two things: carbon dioxide gas and water. So if we write this equation out, we see that we have an organic compound that consists of carbons, hydrogens and oxygens. So carbon, hydrogen and oxygen. I just don't know how much of each. So this is X, this is Y, and this is Z. I then burn this in oxygen, which means I undergo combustion, and my byproduct is going to be CO2 plus H2O. Now, when you look at this, you see that all the carbons are in the carbon dioxide. So all the carbons from the carbon dioxide comes from this original organic compound, and all the hydrogens that are in the water comes from the original organic compound. The first question on the worksheet says that you need to determine how much carbon was in the original amount. So we'll put this original question there. Before we do that, we're going to prepare ourselves for this question. So let's put in all the details of what do we know, what's given, and what don't we know. So they're telling us that the carbon dioxide is 1.23 grams, and they're telling us that the water is 0.756 grams. I'm also being told that my original compound has a mass of 0.645 grams. So I took this amount of the organic compound and I burned it in oxygen. It doesn't tell me how much oxygen. Whenever you are working with your masses, you will know that you cannot compare masses in an equation with each other. You will have to convert everything to number of moles. To do that, I would have to determine the molar mass of the different substances that are in this compound, which means we would have to determine the molar mass of carbon dioxide gas, which is going to be one carbon of 12.01 plus two oxygens of 16 grams each. That gives me a total of 44.01 grams per mole. That's the meaning of molar mass. So because I'm going to work with carbon dioxide, I'm going to calculate the molar mass of this one. Secondly, I also am going to do the same for the water. So for water, I have 2 times 1.01, because there's 2 hydrogens, plus 16. So that gives me a total of 18.02 grams per mole. So those are my molar masses of my carbon dioxide and my hydrogen. The very first question that we have to do now is this one, that is related to how much carbon was in the original compound. So I want to find out how much carbon is in this compound. So I'm told that I've got 1.23 grams of carbon dioxide, but please note that the carbon makes up 1/3 of this. I cannot just go and say that 1/3 of this is going to be the carbon. I have to look at the molar masses, and I'm going to have to do a proper calculation to determine that. So to do that calculation, we start with, now remember, dimension analysis means you start by writing down what you know. So I have 1.23 grams of CO2. That's my given. Now I put it over 1 because then it's a fraction. I'm going to first convert my mass of carbon dioxide to find out how many moles of carbon dioxide I have. And to do that, I'm going to use my molar mass. So what is it what I want to do? I want to find out how many mole of CO2 I have. That means at the bottom I have to have grams of CO2. Now according to this, in 1 mole of carbon dioxide I have 44.01 grams of carbon dioxide. So in other words, I'll put the 1 mole on the top and I'll put the 44.01 at the bottom. So now that my grams of CO2 can cancel out my grams of CO2 here. The next step is I'm going to find out how many moles of carbon is there actually in the carbon dioxide. So because I have mole of CO2 here, it means at the bottom I have to have mole of CO2. If I look at CO2, I can see that it's made up of 1 mole carbon and 2 moles of oxygen. That's my formula. My formula tells me the ratio of which my elements stand to each other. Do not confuse this with the ratio, the coefficients that you get in the front. The coefficients has nothing to do with molar mass, and it has nothing to do with my formula. The coefficient has to do with how the substances stand in relationship to each other. But we don't know that now. But what we do know is in 1 mole of CO2, I'm going to have 1 mole of carbon. See, in 1 mole of CO2, I'm going to have 1 mole of carbon. That means my mole of CO2 and my mole of CO2 here cancel each other out. Now that I know how many moles of carbon I have, I will convert that to mass because I want to know what is the amount. If I want to know how much, what is the amount, then it means I need to get it in grams because I know how many grams of CO2 I have. I don't want to know how many moles I have, which means now I have to convert back to mass. So what do I want to know? I want to know how many grams of carbon do I have. If I know how many moles of carbon has a certain amount of carbon. So if we look at the molar mass for just carbon on its own, we see that when we go to the very table, that 1 mole of carbon has 12.01 grams of carbon in it. So now that means I have now got to the end of my answer. If I go and I take my calculator and I put all of this into my calculator, I'm going to get an answer of 0.335 something, but I would round it to 6 because my answer has to be in 3 significant figures. I have 3 significant figures here, I have 3 there, I have 3 significant, so my final answer must be significant figures. And I've just determined how many grams of carbon is in this original amount. Now to do the water, we're going to do it exactly the same way. So how much water do we have? We have 0.756 grams of H2O. I put that over 1. I'm going to multiply that by putting my grams of H2O at the bottom and putting my mole of H2O at the top. Now according to the molar mass of water, 1 mole of water has 18.02 grams in it. Now that I know how many moles I have, I'm going to go and convert to how many moles of hydrogen is in 1 mole of water. So when I look at my formula, I see that there's 2 moles of hydrogen for every 1 mole of oxygen. So I will have my mole of H2O at the bottom, and I see that if I have 1 mole of H2O, I will have 2 mole of H. Now be very careful not to write this as H2, because I don't want to know how much H2 gas I have. H2 on its own with a 2 at the bottom would mean I'm talking about hydrogen gas, and I'm not talking about hydrogen gas here now. I want to find out how much hydrogen is in 1 mole of this water. or not 1 mole in a certain mole of water. So I've worked out how many moles of water I have. Now I want to find out how many moles of hydrogen is in it. So you must just put an H on the top, not H2. Now that I know how many moles of hydrogen I have, I'm going to put that into my grams of hydrogen. And because I have mole of H at the top, I must have mole of H at the bottom. So you see again that these moles of H has to cancel each other out. So I know that in 1 mole of hydrogen, I have 1.01 grams of hydrogen. Put that in your calculator and you'll get a final answer of 0.0847 grams of H. So now I've determined how many grams of hydrogen I have. It means I've also answered the second part of the question, which was B, calculate the amount of hydrogen. When I get to C, C says how much oxygen was in the original sample. This is actually the easy one, because if you look at this, you have just determined how much carbon you have. So you know that you have 0.336 grams of carbon in this original compound, and you've determined how much hydrogen you have in the original compound. It's now possible for you to determine how much oxygen you have. Well, that's very simple. You know that the total amount that you used was 0.645 grams of this CX, HY, and OZ. You have the original amount. So if you subtract from that the amount of carbon, which is 0.336, and you subtract from that the amount of hydrogen, which is 0.0847, then the balance is going to give you how much oxygen you had. Because you can't do the oxygen the same way you did hydrogen and carbon. Can you see that the oxygens are in too many places? There's the oxygen from CO2 came from there and here. The oxygen from water came from there and from here. So we can't do that using this. So we simply needed to know 2 of the substances in our original organic compound, because then it's easy to get the third if you know the total amount of organic compound you had in the beginning. And if we do the subtraction, we see that our answer is 0.224 grams of oxygen. Okay? Now, the next step in our calculation is determine the empirical formula. So let's go to a fresh page. Now, to determine the empirical formula, I need to use my values that I determined in this calculation. So let's copy them over here. So my carbon was a mass of 0.336 grams of carbon. My hydrogen is 0.0847 grams of hydrogen, and my oxygen has been calculated as 0.224 grams of oxygen. Now that you know how many moles of each of those you have to convert it to, or how many grams, what the mass is, you have to convert it to the number of moles that you have. So let's quickly convert this to number of moles. To convert to number of moles, I'm going to multiply this by grams of carbon at the bottom, mole of carbon at the top. So 1 mole of carbon is 12.01 grams. I do the same for hydrogen. I'm going to have my grams of hydrogen at the bottom and my mole of hydrogen at the top. So 1 mole of hydrogen is 1.01 grams of hydrogen. And I'll do the same for oxygen, because I know that I have gram of oxygen at the bottom and mole of oxygen at the top. And once again, I warn you here about not writing H2 and O2, because you are working with oxygen and hydrogen as being part of a compound. They are not on their own. If they were on their own, we would work with them as H2 and O2, but they're not. They are part of the compound. In empirical formulas, you are working with things as part of a compound, so it will never be a diatomic molecule that you are working with. Now when I do the calculation here, I see that for carbon I have 0.0280 mole of carbon. When I look at oxygen and I do the calculation, I see I have 0.0839 mole of hydrogen, and for oxygen I have 0.0140 mole of oxygen. In order to determine the ratio that these elements have to each other, I have to divide by the smallest value here. So I'm going to divide all of them by the smallest value, and my smallest value is 0.140. So I will divide everything by 0.0140. I will divide all of them by that value. When I do that, I'm going to get the following answers. This divided by itself is equal to 1. This is equal to 5.999, which I'm going to change to 6. It's close enough to change it to 6. And this is equal to 2. Now this gives me the ratio in which my elements stand to each other, and that's going to be my empirical formula. In other words, my carbons, there are 2 of them. So my empirical formula is going to be C2. My hydrogens, there are 6 of them, H6. And my oxygens, I have 1, which means I will only write down the symbol O. So now I've determined the empirical formula for this compound. So I've answered that question. My last question that I now have to do is I have to determine the molecular formula. Now the molecular formula is not the simplest ratio, but the molecular formula is going to be the one that's going to show you the exact shape of the molecule and exactly how many of each element you have in it. So according to the information given to you in the question, you have 138 grams of the original compound, which means your original compound, when you add the molar mass, you get 138 grams per mole. So let's quickly add this one to see what is the molar mass of the empirical formula. So that's going to be 2 times 12.01 plus 6 times 1.01 plus 16. And I see that that gives me a value of 46.08 grams per mole. Now clearly the question says that the original compound's molar mass is 138 grams per mole. And I can see that this formula mass here is going to give me 46.08 grams per mole. To find out what the original compound really looked like, I now have to take my 138 grams per mole and divide it by this molar mass of 46.08 grams per mole. I then see that this goes into that value 3 times. So that means that the molecular formula of my original compound is going to be, if I take the empirical formula, I have to multiply everything in that formula by 3. So carbon is going to be 3 times 2, which is 6. Hydrogen is going to be 6 times 3, which gives me 18. And oxygen is going to be 1 times 3, which gives me 3. Right, so now I've answered that last question, which is my molecular formula. The last question in this exercise was you had to draw the potential structure for the compound if you have this empirical formula, and we'll look at that in a lesson on its own.